Okay. Solve the equation by graphing. So the first one is 2x squared plus 8x equals 0. How are you going to solve this by graphing?
We need to find the vertex, y-intercepts, and x-intercepts.
Okay. So how can we solve for the x-intercepts?
By making a table.
Well, first of all, let's do the easy one. How do we solve for the y-intercept? The y-intercept means what about x?
Replace it with 0.
In other words, it's wherever x is 0. So if we substitute 0 for x here, it says 0, so the y-intercept must be right there. Okay? Now, to find the x-intercept, we need to factor this. Help me factor this equation. What's the greatest common factor that I can pull out of both of those terms?
2x.
Leaving behind what? What's the rest of it? What would remain? If I've divided each term by 2x, what remains here?
X plus 4.
Okay, so now if that has to be equal to 0, then what? What's the solution for x?
Negative 4.
That's
Well,
one.
0 and negative 4.
Right, negative 4 is one solution, so that point has to be on the graph, and this point has to be on the graph, x equals 0. Okay, and let me think for a moment. I guess if x, no. So that's the solution. We still haven't really drawn our graph. We haven't figured out where the vertex is. Do you know how to find the vertex of a parabola? We know this is a parabola because it's a quadratic. And
Well, don't you use the equation negative b over 2a?
Right. So that's the x-coordinate of the vertex. So what is b and a here?
B is 8, and a is 2.
Okay, so it's negative 8 over 4, which is equal to negative 2. So the vertex lies along this line of symmetry right there, but we still don't know where the y-coordinate of it is. How do we figure out the y-coordinate of the vertex? In other words, what we just figured out was the x-coordinate. That's the vertex x-coordinate. So what would the y value be? We don't have a y in this equation, but if I plug in minus 2 for x, what do I get? I get 2 times 4 plus 8 times negative 2, and that is negative 8. So the y-coordinate of this parabola is at negative 8. In other words, if I draw the bottom side of it here, and I go down to minus 8, this parabola is going to go down, hit its vertex right there, come back up, and do something like that. And we have the two x-intercepts, we have the y-intercept, and we have the vertex. So when they say
So what was
solve,
the y-intercept? Oh yeah, 0.
the y-intercept was y equals 0, and we got it by plugging 0 in for x and solving. Okay. Okay, so let's look at number 2. X squared, this time let me do it this way. X squared plus 2x plus 1 equals 0. So let's start right off. Let's not graph anything. Let's solve for the y-intercept. The y-intercept happens when we plug in 0 for x. So
Is it 1?
yeah, that's what it would be. When you just take this expression and evaluate it with 0 plugged in for x. Okay. Now, what are the x-intercepts? In other words, what values of x make this true? And what do we have to do first before we can figure it out?
Find what x equals.
But the way we find out what x equals is we have to factor that first. When you solve a typical quadratic that has an x squared, an x term, and a constant, then usually you have to either factor it or you have to apply the quadratic formula. But this factors rather nicely. What does this factor into?
X minus 2 and x plus 2 plus 1.
Now, first of all, the constants have to multiply together to be plus 1. How does that happen? It has to be a 1 and a 1. It's the only way we multiply.
Minus 1 and plus 1.
How about plus 1 and plus 1? Let's go through the technique for factoring. We get this far here. Okay? Now what we do is that we examine the sign on the constant. By that I mean that plus sign. That plus sign tells me that the signs have to be the same. They either have to both be negative or they have to both be positive. And to find out which, we examine the sign on the middle term. Since that's positive, they have to both be positive. So now I know that. And then the last part is these two numbers have to multiply together to be 1. So they have to be factors of 1. Well, there's only two factors of 1, and that's 1 and 1. So that's how we factor.
Oh, okay.
Okay. Now, what's the solution? Where is my x-intercept or x-intercepts?
At negative 1.
Right. In this case, there's just one. And it's at negative 1. So I have my y-intercept at 1. So I know the graph's got to go through that point. I know it's got to go through that point. And that's the only x-intercept I have, which tells me it probably goes down and kisses the graph at 1 and doesn't cross it. Okay, so I can pretty much graph it now. It has to graph like this. And if I solve for my vertex based on minus b over 2a, I get minus 2 over 2 negative 1, so I know that is the vertex. And if I substitute negative 1 in for x, I get 1, I get 0, because I get 1 minus 2 plus 1, which is equal to 0, and that tells me that the y value of the vertex is 0. So now that's all I need to know. I've graphed it. And in terms of solving the equation, the answer is x equals minus 1, and there's only one answer. It's not like the previous one that had two answers. Most quadratics will give you two answers. It's unusual that you get one, and it only happens when it goes down and just touches the x-axis and comes back up. So,
okay.
It doesn't happen when it crosses. Because if a parabola crosses the x-axis, it's got to come back across it again. So there's going to be two solutions. So let's take number 3. X squared minus 4x plus 5. Let's solve for the y-intercept. Plus 5, excuse me. Right. The reason the y-intercept is the easiest one to solve for, because when I stick 0 in for x, this term disappears and so does this, and you only have what's left. So there's not a lot of math to really do in order to come up with the y-intercept. So that's at plus 5. Now how about the x-intercept? Again, what do we need to do to this?
So it's a 2x 0.
Well, we need to factor it in order to find
Oh yeah,
it.
factor it.
So this is x, this is x. Now what next? What's the next step in the process? We examine the sign on the constant, which is a plus. That tells us it's either plus plus or minus minus. Which is it in this case?
It's minus plus.
It's minus minus.
Oh, because
the middle term is minus. The only problem here is the only factors of 5 are 5 and 1. So I don't have any choice, and that doesn't work. So I cannot solve this by factoring it. I'm going to have to apply the quadratic formula. And that will produce the x-intercepts, but maybe we don't need them. I can actually draw this. We're going to need them to solve it. Let's go through. You've had the quadratic formula, apparently. Otherwise, they wouldn't have given you this problem. Is that correct?
Yeah, I think so.
Okay, so according to the quadratic formula, x is equal to what?
0.
No? What's the quadratic formula? Minus b plus or minus the square root of b squared minus 4ac all over 2a.
Oh, no, we haven't learned that one yet.
Really?
Yeah.
Because we need that in order to factor this number 3, which I found a little bit strange. I wonder if that was a mistake on their part.
The one that my teacher gave me, like the equation for...
Your audio all of a sudden went way down.
Can you hear me now?
A little bit better, yeah.
Okay.
Okay,
The formula that my teacher gave me for graphing quadratics is... Oh wait, let me find it. For standard standard form, she told, well, wait. For quadratics, it's y equals ax squared.
Right. Ax squared, actually it's x minus h quantity squared plus k. The thing is that we don't have it in that format. And we can't get it into that format. So given the quadratic that they gave you here, I have no way of figuring out the x-intercepts without using the quadratic formula. So I'm not sure why they gave it to you. Let's do 4 instead of 3. And
Okay.
I'll show you why. I don't want to get into the quadratic if you haven't had it because it can be pretty intimidating. But if we look at 4, which says this, what's the y-intercept?
6.
And to solve for the x-intercept, we need to factor it. This one actually does factor nicely. Help me again.
X,
Plus plus or minus minus?
minus minus.
Because it has to be the same because of that. And it has to be minus because of the middle one. So,
Okay.
so now we're looking for factors of 6 that add together to be 5. So what is that?
2 and 3.
Okay. And then to check, to make sure I don't need to check the x squared term, I don't need to check the plus 6. But I better check the middle term. So the middle term is produced by that multiplication and this multiplication. Well, that's minus 2x, and this is minus 3x. So that gives me the minus 5x. So I factored it correctly. And if that's equal to 0, what are the two solutions?
2 and 3.
Uh-huh.
2 and 3.
Right. So those are the x-intercepts, 2, 3. And let's find the vertex before we graph anything at all. Minus b over 2a. What is that here?
6 over.
Okay, the b is the coefficient of the x term.
5. Negative 5.
So it's a minus b. B is negative 5, so minus a minus 5 would be a positive 5 over 2. So that's the x-coordinate of the vertex, but I need the y-coordinate also. How do I get the y-coordinate?
But we already have our y-intercept.
Well, but notice the problem. Here's the problem. If I try to graph it from the information I have now, I know that it goes through 2, and I know that it goes through 3, and I know that it goes through 6. So I can draw something that looks like this. It's going to go through 6, but I don't know where the bottom of it is. So without a vertex, I know the vertex, the line of symmetry of the vertex is 2.5 or 5 halves, and that makes sense. It should be halfway between 2 and 3. But I don't know this point here. And in order to graph it, I want to know that point. At least if I want to graph it properly. I don't need that point in order to solve the equation. If the only thing I have to do is solve this equation, I solved it as soon as I came up with the x-intercepts. Because the equation says is that this is equal to 0, so whatever values of x make this thing equal to 0 solves the equation. So here's the solution to the equation, but I didn't find it by graphing it. I found it by factoring that quadratic. So I'm not sure exactly what she's wanting here. Solve the equation by graphing it. If we're going to graph it, then we need to graph the whole thing, which is to say we need to find out where the bottom of this parabola is. I mean, I guess we don't need that information, but you're going to at some point. So the way, once we use the minus b over 2a to come up with the x-coordinate, then the vertex of the y-coordinate is merely plugging this value into the equation. So it would equal 5/2 quantity squared minus 5 times 5/2 plus 6. Whatever that value is the y-coordinate of our vertex. Well, let's figure out what it is. That's 25/4 minus 25/2 plus 6. Well, this becomes 25/4 minus 50/4. And how many fourths is 6? That's 24/4. So if I do that math, I get minus 1/4. So this value comes at minus 1/4 right there. Or let me just label that point where I have it drawn as minus 1/4. This is minus 1/4. And now I've accurately drawn my graph completely. And like I said, we didn't actually need that vertex location to solve the equation. The only thing we need to solve the equation are the x-intercepts. We also do not need the y-intercept to solve the equation. We solve these equations algebraically by factoring it, and that's it. So I'm a little confused about what she's looking for here, but there's nothing wrong with graphing this and solving it as two separate problems. But so if we look at this one, what can we do here? This is a quadratic again, so how are we going to solve it? What do you have to do first?
Find a common factor.
We need to factor it. But what's unusual about this? It's got a negative sign in front of the x squared. That makes it very tough to factor. So let's get rid of the negative sign. How can we do that?
Adding 2x.
No. We're going to divide both sides of the equation by -1, which is to say I'm going to divide that term by -1, that term by -1, that term by -1, and that by -1. You can do anything you want to an algebraic equation as long as you do it to both sides. So now what do I have? I now have, that turns into x squared, a plus. This turns into plus 10x, and this turns into plus 25. And that whole thing is equal to 0, because this is still 0 on the right side. So it's much easier to work with this equation than it was to work with that equation. I can factor this one pretty easily. Help me factor this.
It'll both be x plus. And it's plus 5.
So what's the solution here?
X equals -5.
Right. And there's only one solution. That means, again, we're dealing with a quadratic that only touches the x-axis in one spot at -5. So there's our solution, and we got it by just factoring it. We didn't do anything. I didn't have to graph it to get it. I'm puzzled because here's what I find interesting. In order to graph it, I have to solve it. So to solve it by graphing it doesn't really make any sense. You know what I'm saying? I can't graph it unless I solve it. Well, I kind of can. Let's figure out where the vertex is before we figure out anything else. In other words, let's ignore all of our solution. Start with this part right here. Let's see if we can graph it without factoring it first. Where's the vertex? Vertex of the x-coordinates. What's minus?
-5.
What's minus b?
25.
No, minus b is 10. Remember, b is always the coefficient of the x term. And in this case, that's a -10. So minus a -10 is a +10. And then 2a, a is -1, so I got a -2 in the bottom. So you got -5 correct. So that means I have a line of symmetry right there. And I know it's a parabola. And I know it's an upside down parabola. So if I can figure out where the y-coordinate of the vertex is, then I can solve it by graphing it. So how do I get the y-coordinate of the vertex? Because all I solved for was the line of symmetry.
By plugging -5 into the equation.
Okay, so let's do that. So here I'm going to plug it in. You got to be very careful here with your parentheses. So let's figure out what that is. What's this on the left turn into? This part here.
5.
No.
Squared.
The -5 squares to 25, but then we still have this leading negative. So this is equal to -25. I do square the -5 and it turns into a +25, but I still have that negative that is not being squared.
Okay.
Okay? And now the second part is minus 10 times -5 is -50, so that turns into +50. -25, well, that's equal to 0. So the y-coordinate of my parabola is right there also on the line of symmetry. I know that it opens down because of that leading negative, which means my parabola has to look something like this. Now, I didn't solve for the y-coordinates. That would be -25. But just by graphing that part of it gives me the solution to the equation, because the solution to the equation is wherever it crosses the x-axis. So the solution to the equation is x equals -5. And I got that by finding the vertex, not by factoring. I also can get it by factoring, but in this case I was able to get it by finding the vertex, graphing the thing, figuring out that the vertex touches the x-axis only at one spot, and it's where x is -5. Okay? All right.
Okay, I get it.
Okay, let's do 6. So on 6, let's try doing that only. Let's try finding the vertex and see how far we get before we feel a need to factor. So the vertex is x coordinate. What?
For vertex, I got 2 over 6.
Okay, what's b?
2.
B is actually negative 2. In other words, B is this, and this is C, but we don't need C for the vertex, and A is negative 1. So when I do minus a minus 2, I get a plus 2 in the numerator. The denominator, A is negative 1, so 2 times negative 1 is a minus 2. So the x-coordinate of my vertex is minus 1. So I know right there is a line of symmetry for this parabola. Now let's figure out the y-coordinate of the vertex. To plug it in, be very careful again with your negative signs and your parentheses. I'm going to plug in minus 1. Notice that I'm squaring minus 1. I'm not squaring this negative sign out here. Okay? The secret to these is just to be extra diligent with your parentheses and your negative signs. So what does this become?
What does what become what?
What I've circled, what does that become?
Oh, 1 squared.
No. Start from the inside and go out. In other words, if we start with squaring the negative 1, what is negative 1 times negative 1?
1.
Okay, so this whole thing still has this negative sign in front of it, so it becomes negative 1. What does this become?
2.
Plus 2. And then plus 3 means that the y-coordinate of the vertex is at 4. Okay, so if I go up to here, I know my vertex is right there. I know that because of the leading negative sign, it's an upside down parabola. So it does something like this, but I haven't figured out my x-intercepts, so I can't solve it by reading the graph. So I still have to factor it to solve for these 2 points here, which is the solution to the equation. So let's go back and figure out how to factor this so we can figure out where the x-intercepts are. Now, what did I do last time I had a negative coefficient in front of the x squared term? I divided the entire equation by what?
By negative 1.
Okay, and that turned it into, just changes the sign on everything. Now it's quite easily factorable. Now, this is the first one we've come across where we are looking at a negative sign in front of the constant. What does that tell me? What does that negative sign right there tell me about the signs here?
That one's going to be negative and one's going to be positive.
Right. They have to be opposite. They're not the same. So I can do that. Now, I'm looking for factors of 3 that subtract. Because that's a negative, I want factors of 3 that subtract to the number 2. Well, there's only 2 factors of 3, 3 and 1. And because the middle term has a plus sign on it, I'm going to put the larger factor with the plus sign. So I'm going to put this.
Positive 3 and negative 1.
Right. So what's the solution?
X equals negative 3 and x equals positive 1.
Okay, and that's my x-intercepts. There's the positive 1 right there. There's the negative 3 right there. Notice I couldn't really read that from the graph. Excuse me, that's positive 1. I couldn't really read that off the graph. I had to solve it to come up with those numbers. In fact, I have to solve it to even graph it. I can't figure out where those 2 points are without factoring that thing and solving it. I was not able to figure out where it was from the vertex only. In fact, the vertex didn't really do me any good. I went through all of these calculations kind of needlessly because they didn't have anything to do with the solution. So all that did was told me how to graph the parabola. But in order to solve this equation and figure out these x-intercepts, I had to do this process here.
Oh, okay.
Okay? All right. We want to stop there.
Yeah, that's good. I don't have to do number 7.
Okay. Okay. I think that was about a half an hour. So we'll call this a half-hour session and call it a day.
Okay, thank you.
Okay. Thanks, Marina. Bye-bye.
Bye.
You're on spring break all next week, right?
Yeah.
Okay. I'm pretty much off the whole week. If you guys want to do any work, I'm available, but most of the students are taking off the week.
Okay, thank you.
Okay. Bye-bye.
Bye.